Welcome back. This is Physics Unit 1. This is video number 3. Again, we have skipped some material because it pertains to an in-class experiment. We are towards the bottom of page 5 and quick math review on slope. So we learned in Algebra 1 about slope, something about rise, something about run. I'm going to draw a graph here. Remember, the vertical is y, horizontal is x. And let's say that we have a line. So we can figure out the slope of this line as long as we know the actual rise and the run. So we're going to pick a couple of points. Here's a point, and here's a point. And they both have coordinates. This is maybe x1, y1, and this one's maybe x2, y2. But what we can see is that the vertical between the 2 points, that would be our rise, our delta y in physics terms. And from here to here is our delta x, or the change in x. And where the change in y interacts with the change in x, we end up with the slope. So let's write some things down over here. Slope, as we learned in algebra, is rise over run. Putting this in more xy terms, the delta y, or the change in y, is the rise. And the run would be our change in x. In math, a straight line has a constant slope. The slope is the same here as the slope here and the slope here. This is a straight line. Every point on the line is going to have a constant slope. So back to physics. We don't really make charts in terms of y versus x. That's more of a math thing. But there is a lot of overlap here. What we measure is distance and time. Think about our formula. Average velocity equals distance over time. So if we're talking about slope being rise over run, what we're going to do is plot the distance on the y and the time on the x. And you can probably see where this is going. Since distance is on top, distance is on top, we're going to use that as our y, as our rise. Here's our distance, here's our time, and here's a straight line. But we have a known point here, and we have a known point here. And here's what we're looking at. This is the run, this is the rise, and what we have is a right triangle. The rise is the change in distance. This is how far we went. The run is the change in time. This is how long we were moving. So our rise is change in distance, delta D, and our run is delta T. Delta D over delta T, average velocity. The slope of a distance versus time graph tells us the average speed over an interval. This is going to be really helpful as we go through our physics course. Slope of a distance versus time graph, specifically distance time, tells us the average speed over an interval. If the graph is a straight line, then the slope is constant. That means the average speed is constant, which means the motion is what we call uniform motion. If the graph is not a straight line, the average speed is not constant. And the motion itself is not uniform. We can find the slope of a straight line, but what about the slope of a curve? So let's say we have a graph and it looks something like that. And so let's say I want to know the slope at this point. And let's say I want to know the slope at this point. And I want to know the slope at this point. What are we going to do? What we do is we look at the tangent. And if you remember from geometry, here's a circle. The tangent is a straight line along the edge of that circle. We can find tangent lines on a graph by using a ruler. And it's hard to really show you without actually showing you the ruler. I'm just going to try to freehand this. So the slope of this point here I know you can't see this, but I have an actual ruler up here. The slope at that point follows the tangent line. Putting a ruler up for the second point, the slope follows this new tangent line. And for my third point, there's the tangent line. And the reason that this is useful is because I can find the speed at one particular point. If this were neatly drawn on graph paper or maybe a computer graph, we could see how these lines intersected with the actual lines on the graph. So let's say that here's an intersection of the grid and here's an intersection, and now we have two known points for the slope of this line, and we could find the speed at this point right here. And that's something that we will address more as we go throughout this unit and the next couple of units.